Hello, my name is Mark Nuttall. I'm a software engineer with IBM. Welcome to the recording of my talk, When the Tekton Cat Misbehaves, Pitfalls, Mistakes, and Lessons. So, what's this about? Clicks next. Go on. Okay, so what am I going to be talking about? I'm going to have to give a quick introduction of what Tekton is, for those of you that have wandered in and not used it before. And then we're going to talk about a number of ways in which Tekton can go wrong. Now, this is very rarely at runtime once you've got it all set up, but these are ways when you first get hold of Tekton, if you're downloading it, you're trying to use it, you're trying to test it, it's got a few wrinkles, and that's going to be one of the things we're going to be talking about, ways that it just can misbehave on you. When I first put the abstract for this talk in, back at the end of the year, the end of last year, Tekton was still in alpha. Now, since then, it's progressed. It's put out multiple beta releases now, and it's continued to evolve and change and improve. So, several of the ways in which Tekton used to lead you down strange paths or misbehave on you are, I won't say not possible anymore, but much harder to get to because of the changes that are made in V1 beta. So I'm going to be kind of splitting up. It can still do these things to you. These things are much harder to see anymore because of the changes that were made in beta. And then finally, we'll have a look at, okay, Tekton's a system built out of custom resources. How does that help it? And what are some of the impacts or consequences of its cloud-native, Kubernetes design? Okay, so Tekton is an open source project, part of the CD Foundation, out there on GitHub or tekton.dev, where you can get to the website. It's primarily for building CI/CD systems. That's what it's most useful for. Essentially, though, it runs commands in containers in an orchestrated order. So the images that you're building are things that you can build yourself. And where you run it doesn't affect where it deploys to, obviously. It's got an increasingly rich catalog of pre-built tasks, and that's only become more true as we've gone through this year. So it's got lots of primitive building blocks for doing all kinds of useful and common tasks that you want to automate, particularly in a CI/CD space. It's a proper open source project, governed through the CD Foundation, very welcoming of new people, regular web and conference calls, both in EU and American time zones. So do check out their website and turn up and get involved if it interests you. Okay, so here's a typical sort of thing. What might you want to do with a Tekton pipeline? Well, in any kind of CI/CD system, here we show we've got a set of tasks that we want to do: linting, unit testing, building images, running code coverage. This is really showing that it's not just a linear flow, but an acyclic directed graph, I think is the right term. Essentially, a set of tasks that run in an order where some may need to finish before others can need to run, some can run in parallel, some are going to be sequential. So, building blocks. The most basic idea in Tekton is this idea of a step, which is essentially one or more commands to be run inside a particular image. That gets mapped to a single container at runtime. So the first custom resource that Tekton introduces is that of a task, which is a sequence of steps that are going to run in a sequential order. And a task is the thing that gets put in the catalog, and so it's the first really reusable piece in the Tekton design. So tasks do specific things. And it's all going to run as a pod. So we know that a step is a container, so we're going to aggregate those containers into one pod, one task. Then the pipeline is what sequences the set of tasks that we have to run. So It's going to be an ordered list of tasks with the conditions about when they run and how, and then we're binding in other resources and configuration parameters. In order to make something happen in Tekton, you create a pipeline run. So you can think of a pipeline as a class and a pipeline run as an instance. It's a single build, a single running instance of a pipeline. You can kick them off manually. Typically, these things are going to be running dynamically from webhooks or driven by other events or triggers. And Tekton has a triggers subproject that specifically deals with, okay, what might have happened? What events might have happened that you want to use in order to generate pipeline runs and create templated instances of them? So at this diagram I show, we have these static instances, if you like, of steps, tasks, and pipelines. By creating a pipeline run, at runtime, we're spinning up pods and containers, and that's how the pipelines look at runtime. Now, we're going to want to share a workspace, a file system between tasks, and so it's very common to use a persistent volume to map to provide essentially a shared file system across those tasks. Okay, so you've just picked up Tekton, you've downloaded it. What are some of the things that can go wrong, and what does that look like? There's several I'm going to touch on. One's to do with the availability of dynamic provisioning in your cluster, and then you might have too many secrets, you might have too few secrets, and particularly in the alpha versions of Tekton, there were some issues with copying data between steps and oddities in how pull requests would be handled. But V1 Beta shields you from these, so I'm going to touch on them, but not go into quite so much detail about how you can see them going wrong, because you shouldn't see those so much anymore. All right, so in the previous slide, we talked about how pods can share these persistent volumes, and that's a common assumption. In the old days, if you used Tekton before it went into beta, there were ways in which these persistent volumes could be created implicitly for you, and so you may not be kind of warned that persistent volume claims would be created. And that's the first class of problem that you can run into. So, for example, let's create a single task. It doesn't do very much. It's essentially hello world. But we're going to get hold of we're going to check out a Git repository, because that's frequently the first thing you do in a Tekton pipeline. Now, as soon as we want to pass that Git repository on to the next pipeline, next task in the pipeline, this thing hangs up forever. CTL get pods, we see everything's stuck in pending. And right down at the bottom of the description about the pod, we do a kget pods, kubectl get pods, we see it has these unbound persistent volume claims, and so everything's hanging up. And finally, if we dig through the YAML in that description of the pod, we see that, yep, this pipeline run here is mentioned, it's trying to mount some persistent volume that isn't happening. And that's because we said that there were multiple tasks in the pipeline, we provided an output from the Git resource. It implicitly went and created a persistent volume claim on us. So if we run that in a Kubernetes system without a default dynamic provisioner, the whole thing can hang up. Now in beta, it's less easy to run into that problem, because the beta version of Tekton introduces this idea of workspaces, which are an analog of a shared file system. And workspaces need a volume claim template. You need to say, this workspace needs a volume claim. So the fact of having to specify a volume claim can alert you or remind you that, oh yeah, I need dynamic provisioning in my cluster, otherwise this thing isn't going to work. Okay, so having got past that, your pipelines are up and running, but the next thing that we tend to run into is problems with credentials. So, well, let's do something. What we're going to do, we'll clone a repo, do a Docker build, Docker push, see what happens. So we're doing a Docker build. In this case, I'm using Builder. You might use Canico. There are several other ways of building images on Kubernetes clusters. Everything looks good until it doesn't. We tried to push this out to Docker Hub, and now authentication is required, and everything falls apart. So, how do credentials work in Tekton? We've got three things. Pipeline run, the running instance, that references a service account, and the way Tekton works is that the service accounts that you use to run to associate or to run your pipelines need to say which secrets they're going to pick up. So essentially you need to create secrets with annotations on that Tekton will use, list them in your service accounts, and then finally reference them from your pipeline runs. And it's these annotations here that say what these secrets are for. So this is a Docker secret. We have this Docker annotation on. If it was a GitHub secret, we'd have a Git secret here instead of GitLab. Okay, so having created the secrets, we then frequently talk about patching service accounts because you may well use a kubectl patch to add it in. So, all right, fine. If we apply this Docker secret and patch it onto the service account, which is adding this extra line on the service account to say that the secret is now in use, then, oops, sorry. I'm so sorry about that. Okay, so having run the patch on the service account, rerun the pipeline, then life is good and the image gets pushed. Okay, so what if we need more than one credential? What if now I need one for GitHub? I use another one for GitHub, I need another one for GitLab. Let's add a second, if we add a second Docker secret, maybe I've got multiple people that want to talk to Docker Hub. So we patch a second secret on, start our pipeline up, and it immediately fails. So what's going on there? Well, if we describe the pipeline run, it says failed for unspecified reasons. That's not very helpful. If we look at our pods, we see that they're in this init error state. If we describe our pods, we get this hint that a credential initializer init container has fallen apart, has died. So Tekton has a command line interface that comes with it called tkn, and tkn is your friend. If we do a tkn logs to get the logs of the pipeline and say we want all the containers listed, finally we get this clue out in the logs, invalid value, Docker 2, multiple entries for URL. This is the thing. You can't have multiple credentials for a single external resource. Now, we could also have got that out through kubectl, but in kubectl, you need to specify the name of the init container that you're particularly interested in. If you just say all containers, you won't get anything. So tkn is your friend if you're working with Tekton pipelines. So what does that tell us? Well, the consequences of this are that if I need to have multiple credentials for a single repository, a single resource like GitHub or Docker Hub, you essentially need to patch them onto different service accounts. And so you need to choose the service account that's got the credentials on that you want. The alternative is that you simply don't do that and you end up with using functional identities rather than those pretending to be particular users. All right, so we said dynamic provisioning. We typically need that to be enabled. We need to patch our secrets onto service accounts. And this idea that if for a whole of GitHub, you can only put one credential onto one service account. So Tekton typically doesn't run as somebody, it tends to run on behalf of somebody. So you tend up creating an identity that Tekton will use for dealing with all the repositories that you're interested in for a particular service account. that's sort of a consequence of the way that secret handling works. And we've shown that the tkn command line, both for starting pipelines and following their logs, looking at their logs, it's particularly helpful. It's quicker to get information out using the tkn than what you can dig out with kubectl. So it's a very useful command line and one that's well worth using with Tekton. Okay, so briefly I want to touch on some of the good things that have happened in V1 Beta 1. When Tekton came out, it had this idea of pipeline resources, things that were abstractions for external systems and objects. It has ones for Git, pull requests, images that you might build, clusters you might deploy to, storage systems, cloud events. These things haven't been ported to beta. They're all still alpha level. And there's a good link here that talks about why those things haven't been brought forward. Essentially, they each have different requirements, different side effects. There's not a lot of consistency. Each thing makes sense in itself, but as a set of pipeline resources, they're neither complete nor intuitive to understand. And so what they've done instead, is to create a set of tasks in the task library that you can use instead of using pipeline resources. And the tasks are really the way to go. If you're used to using pipeline resources, I would advise you move to using tasks instead from the task library. They are, all of them, excellent replacements, and it reduces the number of different types of thing you have to think about. In the old days, you used to have to copy between resources. We would use these pipeline resources, and each individual task would have to say, right, now copy everything I've done into my output pipeline resource so the next thing in the chain would pick it up. This added a lot of sort of boilerplate and execution time to your tasks. You don't need to do that anymore because workspaces make that problem go away. That's basically it. Workspaces behave in a much more sensible way. They just look like a shared file system. You don't need to do that copying. So V1 Beta 1 has really reduced a lot of the misbehavior that we saw in the early versions of Tekton. Similarly, the older pipeline pull request pipeline resource made it easy to overwrite comments. You could make several comments and just destroy ones that you'd made previously. They were tricky to update the status of. There's much more consistent set of tasks for those as well. Finally, that old Git pipeline resource would implicitly create persistent volumes. You'd have to explicitly copy the results that you've done with it. And because this is an important point, because it ran in an init container, you couldn't mount additional secrets in. I worked with a customer only some weeks ago that were trying to use self-signed certificates on their Kubernetes cluster. And the Tekton Git pipeline resource wasn't happy with that. Now, the solution for them was to move forward to beta so that they could use the Git tasks, and those would allow them then to mount in their particular cluster certificates into those tasks because they're much more configurable. There's really no way of configuring init containers with additional mount points in Tekton. So as well as being more consistent, they're actually more functional in many ways than the old set of pipeline resources. Tekton catalog, it's an ever-growing resource. There's lots of good things in there. They're always, again, taking contributions from people that want to be interested in that. Do have a look at that. Lots of good stuff to pick up. And so we look at, okay, so Tekton's built out of custom resources, and there are a lot of good reasons for doing that and a lot of benefits from it. If you know anything about working with Kubernetes, they behave in the way that you would expect them to do. All the skills that you've got of working with kube in general, role-based access control, kubectl, those things just behave very intuitively for you. There are some oddities, particularly around pipeline runs. If you want to see the logs of a pipeline run, those are in the pipeline run, and so you need to get the logs out of them. So you end up with these resources left lying around after you've finished, And similarly, if you delete that pipeline run resource, then you've lost your logs. Frequently, you may want to persist the logs of your build for much longer than the metadata about it, how many containers, what was mounted in, what the Kubernetes description of it. And that's something I touch on in the next point. I'll come back to that. The other thing that we see is in a traditional build system like Jenkins or Travis, it's common to have your build logic in the repository itself. But we saw that the first thing that we often do in a Tekton pipeline run is clone the Git repository using a custom resource pipeline run and a pipeline that already needed to exist. So if you want to have your build logic in your Git resource, you end up with this problem of double cloning it. You have to clone it once to get the descriptions of the custom resources that you want to apply so that you can now git clone and use it. And so it leads to this point that Tekton isn't, in a way, Travis or Jenkins. There is some assembly required. And if you want to hook it up to webhooks, it lets you do that. And the Tekton triggers support it. But webhooks aren't a first-class concept in Tekton. You need to write your own triggers to glue into the webhooks that you want to send in. A Tekton pipeline can be a load more YAML than somebody. If you're used to Travis, you might end up with 4 or 5 lines of a Travis description that could turn into a lot more YAML for a Tekton pipeline. And that leads to this point that what Tekton really is very good at is a cloud-native microservice factory, i.e., if I have a lot of repositories whose build is functionally identical, they all look the same. I want to do git clone, docker build, docker tag, docker push. That's it. Or I want to run a set of tests in a similar way. Then I can have fewer pipelines than repositories. And that's the sweet spot for Tekton, really, is I want to build a lot of things in the same way. If you have many repositories that all want to contain their own logic, then you need to do that extra work of cloning them first, getting their pipelines, instantiating their pipelines, and then working out how to trigger those things. And there's more assembly required, and you're kind of out of Tekton's comfort zone. Okay, so I've covered what Tekton is, some of the gotchas that you'll see if you just download it and start trying to get the hang of how to use it. We've looked at how it's evolved this year and how it's really emphasizing tasks and de-emphasizing pipeline resources. It's consolidating on fewer concepts. And this growing library of tasks are where the exciting changes in Tekton are and where the growth is, and where I would encourage you to focus your attention if you're picking up and using it. And again, be aware that Tekton isn't an off-the-shelf product. It's a set of piece parts that you can use for building cloud-native CI/CD systems, and that if you're looking to build particularly a lot of microservices in exactly the same way, then yes, Tekton might be what you're looking for. At this point, if it wasn't just a recording, I'd be stopping and taking questions. So thank you very much for coming. I hope you found this useful. Have a great day. Oh, hello. Okay, so hopefully that's hopefully you can still hear me. So I talked about at the end what Tekton is best at, and it is that microservice factory. It is that idea of building a lot of repositories that have functionally the same build logic for them. And so that idea of a microservice factory is what we've seen Tekton be the most use for. And again, if you've got in Jenkins, in a Jenkins-like world, if every single one of your repositories is built in a different way, and you're using Jenkins today and you're happy, then this kind of moves on to Taryn's question about, well, should we consider migrating our pipelines to Tekton? Taryn says, we currently use Jenkins with the Kubernetes plugin, so it initiates a new pod for every pull request. Also, we're afraid we may not get that much flexibility with Tekton. Now, Jenkins is a really mature product. It's been around for a decade, and it has a vast ecosystem of tasks and plugins, and we all know Jenkins can do huge amounts of things. I pointed out Tekton has a library of tasks, but clearly it's nowhere near, and probably will never be anywhere near, the enormous scope that Jenkins has. Now, the Jenkins Kubernetes plugin, as Taryn says, is really good. It does scale properly with Kubernetes. It starts individual jobs. When we've talked to people that use Jenkins, it's often that the longer you use Jenkins for, the more you start seeing the problems with it that tend to be around plugin conflicts. I want to use this plugin, but it doesn't work with that plugin, or these two plugins clash and I can't get a fix for it, or those kind of problems are ones that Jenkins builds tend to turn into over longer periods of time. And so if you want to keep your build simple and know that just because you built it yesterday, you want to be able to build it again tomorrow, Tekton is a much cleaner design, a much more kind of serverless design, if you like, and you don't see that kind of plugin creep that you can see with Tekton. That's certainly true. However, if you're using Jenkins and what you've got works and it isn't broken, why would you consider moving to Tekton or anything else? You'd have to be saying, no, we really are suffering from the plugin conflicts, or there's some other pain or reason for why you would start changing a build system. It's always the case. Engineers we like to build things, but working on your build isn't necessarily going to make you any more productive or deliver business value without good reasons for changing it. Are there any other questions? All right. Well, if no, have I missed? Oh my goodness me, I've missed 2 pages of questions. I feel terrible. Are there pre-built images for Tekton and the Tekton operator? Yes, absolutely. Lack of Groovy support, lack of a polished ecosystem. Well, certainly work on the ecosystem is where a lot of activity on Tekton is, certainly. Groovy languages for creating pipelines as code, yeah, true. Tekton doesn't have a DSL, and I don't think it's going to have one. You're writing tasks in whatever languages you want to write your tasks in. Does many millions of jobs impact a Kubernetes server, or are there ways to archive builds? Different companies that use Tekton in their builds will do that logging and archiving for you. I know firsthand that IBM's Tekton-based build pipeline in our public cloud, yes, we do that work of archiving those logs for you so that they do persist beyond the duration of your pipeline runs. But if you're building your own Tekton-based system, that's a problem that's left for you to solve. So you need to, most people, you want to get a Tekton-based build from somebody rather than build your own yourselves. Can you use an existing pod to run tasks? No, every task starts in its own pod. JenkinsX uses it under the covers. I'm not an expert in it. It's been some time since I've used JenkinsX. JenkinsX has a lot of opinions and you will accept all of its opinions or none of them. So you need to look very carefully at Jenkins X. If you agree with it in every particular, then it's going to give you a lot of value. If you disagree with it anywhere, you need to move on. Is it more designed to be a toolkit for pipelines, or is it going to be possible to convert between different pipeline services, whether they're kube-backed or not? Jack, I don't really understand that question very well. Really, Tekton runs on Kubernetes only. It's very, very kube-native. I don't think I'm going to properly address that. Slides, please. The slides should be up. Ping me on Slack if you need a copy of the slides and you can't get them. How would you debug a pipeline in case it fails? So often, if your pipeline is going really badly wrong, you end up putting great big long sleeps in your code and you kubectl exec into the pods and dig around to see what's going on. However, that said, normally you're simply running commands in pods that you can run on your local laptop, and 9 times out of 10, if those commands work on your local laptop, it should work in Tekton in kube pods. It's quite unusual for things only to go wrong once you put them into Tekton into pods and run them on Tekton, but it does happen. And yeah, sleep and shell in is very frequently the case if the logs aren't giving you what you need. Does Tekton work well alongside Prow? We do use both Tekton and Prow in the Tekton project. We use Prow does a lot of the approval processes, checking sign-offs, checking that everything has been, checking CLAs and things like that. And then we use Tekton particularly in the release side of things. Now, individual builds, I think Prow is even running themselves. I think they overlap a bit. You can use them both together, but there is some areas where you could use either. Prow is clearly much more complicated, much richer, but a vast project compared to what Tekton is. Tekton is very, very focused on what it does. Prow is much more powerful, much more complicated. Yes, they can work together, but some work is required on your behalf to make them work together. Okay, I've gone 2 minutes over. Again, I'll be on Slack. Do ping me there if you've got follow-up questions. Thank you all for coming. I hope that was useful, and have a great conference. Thank you all very much.